And here's what I'm gonna do. I'm gonna add a static route. Static route can be added using route add if you're using Linux-based console or use Unix-based CLI. But for Cisco, we're gonna use IP route command. Okay, so IP route is the command syntax, and I'm gonna specify this network 192.168.32.0, and I'm gonna do a shortcut. Okay, I'll use /32, and I'm gonna specify the destination. The destination or the next hop IP address will be this reachable IP address. Most of the time, this is if you are initially configuring a static route, most of the time we're gonna apply the IP address of your adjacent device. So in this case, it's R3, specifically 13.2, this IP address. So in other words, router 1 is telling R3, hey, router 3, I want to reach this network via your IP address that I can reach. And we're gonna do the same with R2. On R2 side, we're gonna add almost the same IP route, and we need to reach the 192.168.13.0/30. I made a mistake. This is supposed to be /30, not 32. And then, like what we did in our previous example, we're gonna specify this IP address that can be reached by R2, which is 192.168.32.1. There you go. Now, what will happen here is router 1, let me erase this. Router 1, it's not only it can reach this IP address, it can now reach this IP address because it has now an entry to its routing table. I'm gonna add an entry 192.168.32.0/30, and this is learned via E2. We learned it using static routing. Now, when it tried to ping this IP address 32.2, router 2 can now reply back. Why? Because this network 192.168.13.0 is now learned via R2, and this is learned via E1. This is learned statically because we added a static route. Okay, so in short, router 1 and router 2 can reach each other now, but our goal is for router 1 to reach this network. And how do we do that? Well, we're gonna add another static route. I'm gonna add IP route. I'm gonna specify the network 192.168.20.0/24, and this will be reachable via this IP address. Remember, we can now reach this IP address, right? So this will be our next hop to be able to reach this destination network. So I'm gonna do is I'm gonna add static route 192.168.20.0/24, and the next hop IP address would be 32.2. There you go. Now, for us to get our return traffic, meaning if I send traffic to this network, I should be able to receive a response. I'm gonna add another static route. Okay, IP route. All right, let me correct myself. If we ping or if we send traffic from router 1 to server C can now reply back to router 1 because router 1 is still using this network 192.168.13.0 network. Okay, now what I was trying to say is if you initiate the traffic from PCA or PCB to server C or server D, for server C or server D to respond back, we need to have this network 192.168.10 10.0 network to its routing table, or R2 routing table. So I'm gonna add the next hop IP address, which is 13.1, this IP address. So let me remove this, and I will add the network. This is static. And then I can now add 192.168.20.0/24 via E2. You know the color coding? I will be using yellow E2 E2 because this is the interface where we can only forward the traffic to this network and this network. Okay, I will also gonna add this network 192.168.10.0/24, and this is learned via E1 of router 2. Okay, so here's what's gonna happen now. If PCA or PCB sends traffic to server C or server D, it will send it to the default gateway. Router 1 will process it. It will check its routing table. Hey, you have a destination of 192.168.20.0 network. Let me check our routing table. If we have a network in its routing table. So as a matter of fact, we do via E2. Okay. Now, in our routing table, we can only reach it via 32.0 network. As you can see, the next hop is 32.2. Now, we're gonna also check if we can reach this. Well, we can reach it. So what will happen is the network is via router 2, but before it reach this network, we need to go to router 3 first. So basically, we'll have multiple hops. Router 1 to router 3, then router 2, until it reach this network, forwarding traffic to server C. Now, if server C respond back, it will respond back via the default gateway. Router 2 will send the traffic to the next hop, and then router 2 going to the original source, which is the PCA.